This is ELEC 1510 Logic Design Lecture 7 Video 2 on Don't Care Conditions, corresponding to textbook section 3.5. Don't care conditions come up whenever we have a machine that we're trying to design that has inputs represented by bits that we would never expect to encounter in the normal operation of the machine. That means that the output can be either a 0 or a 1, and it can be either one of those to optimize the function because we'll never expect to encounter it, so we don't care what it actually is. Don't cares on truth tables or K-maps are represented by x's, and they can be either 0s or 1s depending on how the function is optimized. So let's just start with a quick example. A function is going to output a 1 if the input is binary 0, 2, 4, or 5. It won't ever encounter an input larger than 5. So for the full range of binary inputs that we expect to see, 0 through 5, we need 3 bits, 0, 0, 0, and 1, 0, 1 for 0 and 5. But we don't ever expect to encounter an input larger than 5. So the inputs 6 and 7 are represented by 3 bits, but we'll never expect to see them. So in the truth table, those would be don't cares. They can be either 0s or 1s to optimize the function, but we don't care what they actually are because we'll never expect to actually see them. So now let's fill in the 0s and 1s for the rest of the truth table. There's a 1 at 0, a 1 at 2, at 4, and at 5. At 1 and 3, we have 0s. So now let's move on to what this looks like as a sum of minterms and a K-map. The sum of minterms is the sum of lowercase m 0, 2, 4, and 5 for the actual minterms that are 1, plus sum of lowercase d 6 and 7 for the don't cares. So let's fill in the don't cares first. That's 6 and 7 as the minterms in the K-map. And I have to place the variables x, y, and z. And now let's fill in the 1s at 0, 2, 4, and 5, and 0s at 1 and 3. Now we can circle bubbles in the K-map in order to come up with an optimized expression. There's a large bubble here. That has both 1s and x's in it. Again, you want to make the bubble as large as possible without circling any 0s, which means that you can circle 1s and x's. You don't have to circle all of the x's in the K-map, but you can use them to make your bubbles of 1s as big as possible. This bubble corresponds to the term x. Then we can circle a large horizontal bubble, which corresponds to the term z prime. The optimized expression for this function, f1, is going to be x or z prime. Because of the don't care conditions, we actually don't need a y in this function at all. Okay, now let's look at a more realistic example, and more complicated. A machine takes a BCD number as its input and will output a 1 if the number is 6 or less. BCD only goes from 0, 0, 0, 0, which is decimal 0, to 1001, which is 9. 1010 is A in hex or 10, but in decimal that's 2 digits, and so that's not represented in BCD. Therefore, anything that has a BCD input is going to require 4 bits, but there's going to be a bunch of don't cares because a lot of these inputs are not actually BCD numbers. So anything from 1010 all the way up to 1111 is going to be a don't care condition because they're not BCD inputs. So then let's fill in the rest of the K-map. 6 or less will produce a 1. And then 7, 8, and 9 will produce a 0. Now let's look at optimizing this function. These are in terms of what I call digit 1 through digit 4. So when we look at that as a sum of minterms, it is the sum of minterms 0, 1, 2, 3, 4, 5, 6, and the sum of don't cares 10, 11, 12, 13, 14, 15. So let's go in and fill in the ones first. That's 0, 1, 2, 3, 4, 5, 6. Then the don't cares are 10, 11, 12, 13, 14, 15, and then zeros for the remaining minterms. So now we have to circle all possible ones, and we can include any x's that allow the bubbles to be maximized. So let's look at this bubble right here. That one cannot be expanded up or down because there's no room to expand. It can't be expanded to the right because there's a 0. And it can't be expanded to the left because of these two zeros right here. So this term is one of our essential terms, and it is d1 prime d2 prime. And let me fill in on the map what the terms are: d1, d2, d3, d4. So now on the bottom row we have another term here. That one can't be expanded to the left or right because there's no room to expand. To the top there's a 0 in the second row from the left, and we can't expand to the bottom because there is a 0 in the top right corner. And this term is going to be d3, d4 prime. All right, we still have two ones left in the second row from left that we have to circle, and there are two potential bubbles. You could either circle this bubble, which can't be expanded, or you could include the don't care term, this bubble. Either one of those is completely equivalent. Neither one of those bubbles can be expanded, and the function would work either way. I'm going to just use the bubble that includes the don't care terms, which is going to be d2, d3 prime. So then in total, the function is optimized as d1 prime d2 prime, or d2 d3 prime, or d3 d4 prime.